so 3.1, which is 3.1 functions, basically. 3.1 is functions and function notation. So, all right. So here we go. We're going to start off with, this is question number 1. It's got a bunch of graphs on it. So this is going to be quick and easy, this first one. Basically, they're saying select all of the following graphs which represent y as a function of x. So they're saying which are functions, basically, is what they're saying. Which one of those are functions? Anybody ever heard of looking at a graph and saying if it's a function or not? You seen that kind of thing? Yeah. What do you do? So basically, if a vertical line, like the y-axis, straight up and down, vertical line, if a vertical line hits 2 points, then it's not a function. Basically, we don't want that. Now, it seems kind of crazy. Why don't we want that? We'll talk about that in a minute. But let's first just get used to it. See how this hits 2 points? Then no, that's not a function. The next one, this straight line here, every straight line will only hit 1 point, huh? So we'll check that box. That one's yes, it's a function. Does that make sense? It's as simple as that. If a vertical line hits 2 points, it's not a function. We don't want vertical lines hitting 2 points. How about the third one down there? Every vertical line only hits 1 time, huh? Perfectly vertical line. So that one, we'll check that one. We'll say yes. That one's a function also. Good. They want you just to check the boxes down here, selecting the ones which are functions. How about this is the same question. Keep going. Oh, that's the same thing right there. Those two. How about this one? Is this one a function? Yep. These are both yes, yes. Is that good? Next one. Are these ones functions? Is this a function? Yeah. Every perfectly vertical line hits only 1 point. Right? So yes, that's a function. Is the last one a function? No. Here's a vertical line that hits 3 points. 2 or more. No. That one's not a function. It's as simple as that. So if a vertical line hits more than 1 point, 2 or more, then it's not a function. We don't want a vertical line hitting more than 1 point. Now, why not? It's kind of a weird thing. Well, what it is, if something is a function, let me give you the more formal definition now to make sense out of that little test we just did. That test we just did is called the vertical line test. If a vertical line hits 2 or more, 2 or more points, then it's not a function. So why? What's a function? Every x must have only one y value. That's what a function is. You want every x to connect to only one y value. You don't want an x going to 2 y values. That's not a function. That's what we don't want to happen. Every x must go to only y. Do you see the problem with the vertical line test now? Let's go back. See right here at 1, this is the x-axis here, right? X-axis. At 1, see how it hits right here on the y, and here on the y, and here on the y. It has 3 different y heights it hits. That's why it's not a function. Because that's an x value, 1, that has 3 different y values hitting it. That's why the vertical line test is the appropriate test on a graph. Because if it hits more than 1 point, it has more than one y. Now, let's look at the table and do the same thing. Do it up there. Yeah, right here. There's a better picture. Look at that table. So now we're going to do the same thing. Which of those are functions? Same rule. Every x, we want, if every x, only one y, then it is a function. So it's a function if every x has only one y. How about this first one? Does every one of these x's go with only one y value? Yeah. Function. Yes. How about the next one? Yeah, do you see the problem with the next one? See the x value 2 goes with 1 and with 6. No go. We don't like that. That's a big no-no. We don't want the same x number, 2, going with 2 different y values. That's the big no-no. That's the big thing we don't want. We don't want the same x going with 2 different y values. That's not a function. So I know that probably seems kind of weird, but if I can make a real life analogy for you, functions are like toasters. A toaster's a function. Right there in your kitchen, you got a function. And what am I talking about? A toaster, what do you do with a toaster? You put bread in, out comes toast. Put in frozen waffles, out come toasted waffles, right? So a function is just something you plug stuff into and it connects out with an output. So how would it be if your toaster wasn't functioning as a function? That would mean the same input, X is like the input, produces different outputs. You put in bread, sometimes you get out toast, sometimes you get out frozen waffles or toasted waffles. Who knows what's coming out of that thing? That'd be crazy, right? That would not be a function. That's what we don't want. One X must go to one Y. How about this third one here? Is this one a function? Yeah, every X is going to only one Y. It's a yes. How about the last one? Is it a function? No. You have the same X there going to two different Y's. That one's a no. Easy enough? Now, number 3 talks about one-to-one. One-to-one. I think that's pretty obvious. 1x to every 1y. So not only 1x for 1y, but 1y for 1x. Notice both ways. Both ways. You want no confusion both ways. So let's see. That's, I think, pretty obvious. Is this first one 1 for 1? Or is there any repeating? Right here's repeating. The x value of 9 goes with both 8 and 15. No. How about the next one? Does this have any repeating? This y value of 8 goes with both 9 and 13. No go. How about the third one? Any repeating? It's good. Yes, it's a 1. Now that's a one-to-one function. Meaning there's one x value for every one y value. That's what we like. And we'll talk about y as we go higher. And now, back to the graph thing again. This time, they're saying 1-to-1. Not just function, like they did last time. Now they're saying they want it 1-to-1. What does that mean? Remember what we said last time? Every vertical line must hit only one point, right? Must hit only one point. Right? That's what we said before. That was the vertical line test. You can't have a vertical line hitting 2 or more. Well, now for 1-to-1, we're going to say also every horizontal line. So if you want 1-to-1, then you got to have not only vertical lines hitting only one point, but horizontal lines hitting only one point. So we just test vertical and horizontal lines. Here we go. So what do you think about this first graph? Is there any vertical? It's got to be straight up and down perfectly. You can't make any slant to it. Straight up and down or perfectly sideways lines that hit more than 1 point on that first graph. Yeah? If I put a sideways line like this, it's going to hit a whole bunch of points, isn't it? So that one's a no. It's not 1-to-1. So you get the idea? We started with function, just function, not 1-to-1, right? Back here, we started with function, and we just said, okay, every vertical line, if it hits 2 or more, then that's bad. It can hit only 1. That was just vertical lines to be a function, right? And then now we're saying, now we want more. Where are we at? I'm going too far. We want 1-to-1. So that means vertical and horizontal must hit only 1. 1 for 1. So how about the second one? Does that one pass the vertical and horizontal line tests? Does every horizontal line hit only 1 point? Yep. Does every vertical line hit only 1 point? Yep. He's a yes. Is that making sense? If every vertical line hits only 1 point and every horizontal line hits on points, then it's a 1-to-1. There's 1x for every 1y. How about this next one? It's the same as the one down there in the bottom. Is this one good? Every vertical line only 1 point. Every horizontal line only 1 point. Yes. That one's good. This one, no way. 2 points. No. Quick and easy, right? Next one. Every vertical is good. Every horizontal, yes. Last one. It's actually good. Every horizontal line only hits 1 point. Every vertical only 1 point. Yes. All right. So those will be quick and easy for you. On to number 5. Looking at graphs here. Function notation. The plot below represents a function. Question, comment?
That last one. See where it curves
Jogs?
that?
The little jog? Yeah.
Yeah, that little jog there where it curves into.
Right?
Curves up, curves there.
But still, every horizontal line will just hit one point.
Yeah, but wouldn't that be two on that curve up? Is that 2 different y points there?
Well, it never goes perfectly vertical. It kind of goes, well, it looks close, doesn't it? Yeah, they made it so close. But yeah, it never, that might look like it hits, but in reality, it's like that. They're really, if you expanded the graph, there's really only one spot. It's just, they kind of just smushed it together. Yeah, no, there's really only one spot there. It's good. It's a good graph. Yeah, it's just, they made it smushed. All right, let's take a look at this one. Let's evaluate f of 2. So now, then it's basically about reading graphs with function notation. And all you need is the key to the reading, and here it is. This is x, and this is y. So notice, whatever's in the parentheses is x-axis, and whatever it equals is y-axis. That's the key. You just have to make sure and this is the x-axis, and this is the y here. All right, so when they say find f of 2, on this first part here, we have to ask ourselves, is that 2, is that an x value or a y value? Well, if it's in the parentheses, and that 2 is in the parentheses, it's an x, isn't it? So they're saying, hey, go to x is 2, and go up to the curve, find your point, that'd be right there. What's the coordinates of that point? Yeah, over 2, up 4. X is 2, y is 4, huh? That's the point on the graph right there, right? Remember graphing? So from the center, it's over 2, up 4. That dot on the graph is 2, 4, x, y. So they're saying, for this function, this is our function out here. For this function, if x is 2, what does it equal? What y value goes with x is 2? 4. There's nothing to calculate. It's just about reading the answer off the graph. Let's try the second part. The second part is saying, hey, find the x value that goes with this 2. Now, since that 2 is off to the right, it must be the y value of 2, huh? So they're saying, now find the point on the graph that has a y value of 2. See how the 2's, right? So on the first part, the 2 was in the parentheses. That's always x that's in the parentheses. On the second part, the 2's on the right side of the equal sign. That's always y value. So this is the key to the language of functions on a graph. Whatever's in the parentheses is x, whatever comes out equal is y. So now the second part is saying y is 2. So find the dot on the graph at a y value of 2. Do you see it? Right there? This is y2. And what's the coordinates of that point? From the origin, how do you get there? 1, 2, 3, 1, 2. Right? Remember, coordinates are from the origin. So from the origin, you go right 3, up 2. Like that. Thank you. Right 3, up 2. So that's the x and y value of that point. So we found a y value, a point with a y value of 2, and they want to know the x value that's going with it. Answer is 3, right? That's the x value going with the y value of 2. Same kind of thing on this table question. They want us to take this table, and when they put the 2 in the parentheses, is that an x or a y? Again, that's x. So they want you to go find x is 2 and give them the y value that goes with x is 2 from the table now instead of from a graph. Do you see it? What's the answer? 86. It's right there, huh? This is x value 2. And this is f of x. F of x, by the way, is the same as y. F of x is the same as y. Whenever they say f of x, they mean y. Same thing. 86. Everybody see what we're doing there? We're just connecting x and y, or f of x, same thing, values. How about the second part there?
1.
So this 6, is this 6? It's f of x is 6, huh? So it's right there, yeah, and it goes with x is 1, doesn't it? Everybody see that? All right, on to number 7. So now they're giving me an actual function, and they want me to plug in some values to it. So remember how to do that? You've done that before? Let's, in fact, let me get a little room for us back here. And we'll try that one. So number 7. So we're going to say f of x equals 4x squared minus 4x plus 2. And they want me to start first by finding f of negative 2. So remember, whatever they put in the parentheses, you plug in for x. It goes in those x slots, doesn't it? So it becomes 4 times negative 2 squared minus 4 times negative 2 plus 2. Does that make sense what I did there? Whatever's in the parentheses goes there and there, which is where x was, right? It's going into the 2x slots. So whenever you plug into a function, you put parentheses around the number and stuff it in to the x slots. And then you just work it out. So what is that going to equal?
6.
Is that it? Well, you're quick. Yeah, you can just use a calculator, whip it out. This is going to be 4, negative 2 squared, because that's negative 2 times negative 2, positive 4. Just use your calculator. And then minus 4 times negative 2 is plus 8, 2 negatives. And then this is going to be what? 16 plus 8 plus 2. Yeah, 26. Is that good on that? Want to try one of those? How about the next one? The next one says f of negative 1. So same function, this time plug in negative 1. So 4 negative 1 squared minus 4 negative 1 plus 2. Yeah, so that comes out 4 times positive 1, right? Because negative 1 squared is negative 1 times negative 1, positive 1. Minus 4 times negative 1 is plus 4, huh? 2 negatives, multiply to be positive. Just use your calculator. 4 times 1 is 4, plus 2 is 10. Right, and there's other ones, be the same thing. I'm going to move on to number 8 on that. They're going to give us f of x is negative 3x squared minus 8x plus 8. And they're going to ask us in part A to figure out f of negative 4 plus f of 4. Does that make sense what you do there? That means you're going to plug negative 4 into that whole function and work it out. Then you're going to plug positive 4 into that whole function and work it out, and then add the two results. Right? That good? So now starting here, we'll take minus 3 and plug in the minus 4. Oops, minus. And then the second part over here. And we're going to put a big plus sign in between them. It's going to be minus 3 times 4 squared minus 8 times 4 plus 8. And then right in the middle of them, we put a big old plus. Then you just work all that out. Hey, actually, let me change my mind real quick and do the harder one for you. Part B, I'm going to change to Part B. Part B is the same thing, but they stick a minus in the middle. Let me show you about that. So what if they do the same, everything else is the same, but there's a minus in the middle now on Part B. And how do you handle when you got a minus in the middle of two big old expressions? Do you remember that you got to put parentheses around them? Because that minus is going to change whatever signs are on the right. Didn't really matter with a plus sign because pluses don't change anything, but minuses do, so we have to be clear to put the whole thing in parentheses and work it out on that. So let's work it out now. So now you just crank it with your calculator. What is it? 16. And that's going to be plus 32. It's going to be minus 3 times 16 minus 32 plus 8. That'll be minus 48 plus 32 plus 8. And then the other side, minus 48 minus 32 plus 8. And then we can finish it up. This is a messy one. Plus 40, is it minus 8 over here? Minus, and that's, I don't know, minus 80, minus 72, I think. Did I do that right?
Yeah.
Okay. We all good to there? Am I racing ahead of you? Specifically, what do we do with this minus and this minus? Positive, right? Two minuses head to head become add, don't they? So what's that? 64? I think 64 is the answer. That good? You good with all that? So I did part B, which was the harder one on that. Good there. Questions on that one?
How did you turn that 72 into a positive?
Right here, when the two negatives are head to head, remember two negatives make positive. Yes, when you have two negatives head to head like that, they make positive. On that. If we just had one negative, it would stay negative. If you have two negatives, it becomes positive. All right, let's do, let's take a look at this. So I'll just give you the names. When we come back, we'll do the graphs. Let's see what you know. I bet you know a lot of them. How about this one first off? Square root of x. Well, I just said it, huh? So it goes right there, doesn't it? All right. What about the next one? Yeah, that's cube. The third is cubic, huh? Exactly. All right. See what you know. How about that one? Yeah, well, the reciprocal is actually this one.
That's the reciprocal square.
Totally right. There it is. They have reciprocal squared. That's exactly what it is. Yeah. Good. All right. Next one. This one. That's just squared, right? They don't seem to have that, do they? Oh, it's also called quadratic. Quadratic means x squared. That's another name for x squared. That's it. All right. And then what about the next one? Cube root. Yeah. And then this one, you know, absolute value. And finally, that's just linear. Just regular x to the first power. That's linear. So that's the name of all those little functions like that. So here we're on the next one. Now we want to try to match up those functions with their graph. Does anybody know how these work? Let's start here with this one. Anybody know which one the V graph is? Nobody, no guesses?
Absolute value.
It is. Good, Genesis. Absolute value. Yeah, because see how everything's positive? Everything's up, right? Nothing's below, nothing's negative. Nothing, no graph down here. Makes the whole thing positive. Okay, next one. What's that one?
What number is this?
What's that? I'm sorry?
What number is this?
I don't know. Is it number 8 or 7 or something? 10. It's number 10. So what do you think about that part B? It's 1 over x. It's the reciprocal. That's what 1 over x looks like. How about part C? Which one is it? We're looking for these functions over here. Which one of those is part C?
X.
Yeah, that's just x. That's just regular plain old diagonal line x. Yeah. Good. Let's go to the next one. Wait, oh, that's the same thing. That's just the same one again. Okay, what's that? What's the U shape? Which one of these over here makes a U shape? Yeah, quadratic, the x squared. That's right. X squared makes a U shape. Because again, everything is positive, but it's curved. Now, that's a more tricky one. Anybody know that one? A cube root. And then this one is the cube. The third power ones are both snakes. I call them snakes. This one is a snake going up and down, third power. That one's a snake going sideways because it's a root. Root numbers are small. When you root something, it's smaller. It doesn't get very high. And this one, it's kind of curved up, regular root. Regular root. And then there's x cubed again. And this one, that's the 1 over x squared. Because it kind of looks like the 1 over x. See back here, it sort of looks like this one. It's got those curvy things, but it's all positive. See how this has a negative piece and a positive, but up here is positive, down here is negative, right? Whereas this one, everything's positive. Because when you square it, it's all positive. It makes that go up. You see that? So there we go. All right, on to number 11. Now they want us to do the same thing with tables. This is all just getting used to various graphs and various equations. We're just playing around with these different equations and what their tables look like, what their names are, and what their graphs are. So let's start for the first one. What's happening? This is the x and the y. Whoops, move this here. Oops, sorry. Oh, sorry, guys. I'm doing totally crazy things here. There we go. Okay, x and the y. There we go. X and the y. So what did they do to this -2 to make it -8? What did they do to this +3 to make it 27? It's -2 times -2 times -2 makes -8, huh? They're multiplying it by itself 3 times, aren't they? Just like 3 times 3 times 3 is 27, huh? So they're taking the x's and multiplying it by themselves 3 times. So what function's that? X to the third, huh? Everybody see that? Okay, how about that next one? What's happening here? How does -2 become +2? What's going on? What are they doing to the x's to get the y's? Absolutely. Yeah, they're just making them all positive, aren't they? They're not changing them otherwise. Good. All right, how about part C? Look, that's just weird. There's nothing for -2 and -1, but then the other ones, what's going on there? It's square root. Do you see why there's nothing for negative? You can't put a negative in a root. Remember, that's not real. That's imaginary. You can't do that. That's why there's nothing there for negative. That's why the graph of square root only starts at the origin and curves up to the right. It doesn't go left at all. Because for negative x, it only goes for positive x values. It doesn't exist for negative x values. That's why his graph looks like that. How about D? We got to do D down there. How about part D down there? What's going on? What's happening? How are these x's becoming those things? That's weird, huh? What is going on there? Yeah. Well, good job. 1 over x, right? Because for -2, if you go 1 over, if you divide that in your calculator, it's -0.5 because it's half, right? Half is 0.5 and it's negative. That's how it becomes -0.5. Does that make sense? That's 1 over x. All right. Couple more. What's happening up here on E? How's -2 becoming 4? And what's going on there? What is it? X squared. Yeah, they're just second powering them, aren't they? Right, that's how 3 became 9. And last one, what's going on here? What is that? Well, that's just x. It's just the same exact thing, isn't it? Nothing's changing at all. Yeah, there we go. There we go. All right, a little practice. So that was all about practicing those functions, graphs, tables, and names. All right, to number 12 we go. Given the function, evaluate and simplify the function. So this is really important. So let me get some room here and show it to you. Get some more room for us. So number 12, they're saying f of x equals 5x plus 5. Then on the first line, they're saying, okay, tell us f of a, please. So remember, whatever's in the parentheses, that's what you plug in for x, huh? X is like the holes in the toaster. It says insert here, right? It's the slot in the toaster. So it's kind of like this is what I do sometimes. It's kind of like that. Anything you put in there, like we're putting in A, right? We're going to put in A there. It's going to slide down and show up where the X is, right? So it'll become 5 times A plus 5. And that's it. We're done. There's nothing more to do there. It's just 5A plus 5. You don't have to show the parentheses. You can just write 5A plus 5, same thing. Parentheses don't really matter. I'm just trying to show them for extra clarity. Okay, and then the next part, they're going to say, okay, now we want you to plug into that same function a whole A plus H. So we just do the same thing. This time we're plugging in A plus H into the toaster, and it's going to slide down and show up where the X is. And we're going to get 5 A plus H plus 5. Does everybody see what happened there? We just plugged in A plus H in the X slot. So again, the X is like the holes in the toaster, the insert slot. Whatever you plug into the function, it plugs in right there. Now that one we're going to have to distribute a little, do a little bit of work. Only really one step, huh? Just to finish that one up there. So this 5 is going to go boom, boom. And you get 5A plus 5H plus 5 done. And now, lastly, they're going to ask us to put this all together. They're going to say, okay, now that you got all that stuff, we want you to give us f of A plus H, which is what we just did, minus f of A all over H, please. So we'll say, okay. You want f of A plus H. Well, we just did that. It's this, right? It's 5A plus 5H plus 5 minus, and then you want f of A? Well, we did that right up here. That's 5A plus 5. But remember, I need parentheses around that. Whenever something comes after a subtraction symbol and has more than one item, you have to put parentheses around it. That way you'll subtract the whole thing and not just the front part. Does that make sense? The more that really makes sense, it's not just something Mr. Heron says, it'll stick with you better. If I was to not put parentheses, do you see how that would not be true to the meaning? What do I mean? Well, if you don't put parentheses, you're only subtracting the 5A in the front, you're not really subtracting the 5. Why is that so bad? Well, because they told us to subtract all of f of A, not just part of f of A, right? F of A, right here, f of A is 5A plus 5. I've got to subtract all of 5A plus 5. All of f of A, that says, not just part. So if I didn't put parentheses, I would only be subtracting the front part rather than all of it. Does that make sense? That's why we put in parentheses. So let's do that. All over, what goes on the bottom? H. So everybody see what we did? So we just took those pieces like a puzzle and put them together. F of A plus H, F of A subtracted over H. And then they want me to do a little algebra to clean that up. So what's going to happen? Well, the first part isn't going to change at all. 5A plus 5H plus 5. And then this minus sign is going to go boom, boom. Right? Remember, a minus sign in front of parentheses always distributes. And then the H on the bottom will stay there. Is that good so far? So whenever you have anything in front of the parentheses, a minus sign, a number, whatever, anything right up against a parenthesis wall, it distributes to everything in the parentheses, and then you drop the parentheses, right? And now, can we cancel anything out there? 5a, 5a, 5, and 5. So what are we left with? 5h over h. And what can we do with that? Cancel the h's. It's just 5. After all of that. The difference quotient. And a quotient is a dividing. It's a big fraction, and it's got a subtraction at the top. So we call that a difference quotient, meaning a subtraction fraction. That's what we're basically saying. Which sounds funny. There's a lot of subtraction fractions, aren't there? Yeah, but this is the subtraction fraction. It turns out it's the derivative for calculus. It's how you do the derivative in calculus. So it's really useful in higher math. So it's called the difference. There's a subtraction on the top. Quotient. It's the difference quotient. All right. Well, whatever it's called, let's do it. So first off, this part, f of x plus h. How do we do that? You plug x plus h in here and there. Remember? That's what the x is in a function. It's the insert slot. So I'm going to go 2x plus h squared plus 3x plus h minus, and then parentheses, all of f of x all over h. So if I come back here, let me draw this. All of this right here, do you see that this is really f of x plus h? And this back here, back up this a little bit. Do you see that all of this is really f of x? Do you see that? You see how that's true? I'm taking whatever is right here in the parentheses, and I'm putting it there for x and there for x. All right, now we need to work all that out. That's easier said than it is done. Let's do it. So this 2 is going to sit in the front, and x plus h squared, do you guys know how to do that? How about I do that up here in the corner real quick? X plus h times x plus h. That's what x plus h squared means, doesn't it? Right? X plus h squared means 2 of those x plus h's. Right? Squared means 2 of them. So, let's do it. Boom, boom. X squared plus xh, boom, boom, plus xh plus h squared. And then in the middle, 2xh. I gathered like terms. So there we go. It becomes x squared plus 2xh plus h squared minus. And then I'll just keep everything else the same for the moment. I'm being totally crazy. Let's go back here. Yeah, so that was just that part, right? So this part came right there, plus the 3x plus h, and then the other part, minus 2x squared plus 3x. Thank you. I'm getting confused too. There we go. There we go. Do you see where everything went? Now it's correct, right? See where everything went there? So we've got the 2, and then I multiplied the x plus h, and then the 3 and the x plus h, and then the thing in the back. Right, so I just did the multiplication of x plus h squared over in the upper right and brought it back. See those different parts? Now, we got to distribute. Boom, boom, boom. So we're going to get 2x squared plus 4xh plus 2h squared plus, and then boom, boom. So this came down to here. 3x plus 3h. And then at the back, the minus goes to both. Minus 2x squared minus 3x all over h. What a mess, huh? This is calculus. All right, so what are we going to do up there? 2x squared and 2x squared cancel. Basically, let me give you a hint. All items, all non-H terms cancel. Every term that doesn't have an H, you get what I mean by non-H? They're lacking an H, they don't have an H. You should expect them to cancel. So 3x, he doesn't have an H. He better cancel. He does. Look at that. That will always happen. So I teach my calculus students when we're doing this kind of stuff. I say, all the non-H terms will cancel. Guaranteed. It makes the mess a little more bearable. So all the non-H terms cancel. And so what do we have left then? 4xh plus 2h squared plus 3h all over that h on the bottom, huh? We good there? We're only left with terms on the top that have an h. That'll always happen. The non-h terms cancel. Now, last step. Now you can cancel this h with one of the h's from each of those terms. Just one. So we're left with 4x plus 2h plus 3, and that's the answer. So everybody see what happened with the 2h squared there? Because h squared means hh, doesn't it? There's two of them here. So I canceled the one on the bottom with one of those guys, leaving one left over. So the h on the bottom cancels one from each term. It divides all three of them, right? It's really underneath all three of them. So it divides all three of them. Takes one h away from all three of them. Yeah?
Why do you square root that?
They put in the parentheses, when they say, find x plus h, when they put x plus h into the function, then I'm plugging it in right here and right here for x. Those are the input slots. Those are the holes in the toaster. And that has a 2 in the front and a square on it. So I put a 2 in the front and a square on it. And in the back, I put a 3 in the front. Good. That makes sense? So those are messy, aren't they? Those are important. You can learn them, but you got to practice. Took me a lot of time. You got to practice on that. All right, let's try. I don't know how many of these we want to do. I'm going to try that one. So start on number 14. So one more of these. So let's plug x plus h in there. Just do that part first off. See what you get. What you're doing is you're taking this x plus h and you're putting it right there and right there, right? Because those are the holes in the toaster. So whatever they put in the parentheses, in this case x plus h, put it in there, right? Parentheses x plus h, stuff it in the x. Parentheses x plus h, stuff it in the x. And then just work out whatever. Yeah, so it becomes minus 3, and then we plug in the x plus h squared plus 3, and we plug in the x plus h, and then the minus 8. Good, so we just stuff in whatever's in the parentheses, we just put that in the toaster, right, which is the x slot. And then we have to work all that out. So, so I'm going to take this again off to the side. X plus h times x plus h. That's what that x plus h squared is. And so what does that become? You know how to do that. First to both. So x squared plus xh. And second to both plus xh plus h squared. These two are like terms. So it's x squared plus 2xh. Plus h squared, isn't it? So now I'll bring that back here. So then we have minus 3, and then the x squared plus 2xh plus h squared, like that, plus 3, and I'll just keep everything else the same for the moment, plus h, and minus 8. And then on the next line, that minus 3 is going to distribute. So we get minus 3x squared, minus 6xh, minus 3h squared. And then this 3 is going to distribute. And it'll become plus 3x plus 3h. And then finally the minus h back. And that's it, huh? There's no like terms there. Everything is a different kind of term and nothing can combine. And that's it for that part. And now they're going to have us do one more step. Are we good so far? Now they're going to say, okay, you did well to there. Well, that's a tough one. All right, now get to there. And then they're going to say, okay, here's what we want you to do overall now, the whole difference quotient. That's the first part of the difference quotient. Then on part 2, they want you to do the rest of the difference quotient. So notice that right here, this part is all of this, isn't it? All of that goes there, doesn't it? Because we just did that. Do you see that? We just did that first part. So this will equal, so first thing is all of this stuff, minus 6xh, minus 3h squared, plus 3x, plus 3h, minus h, all of that, and then minus, and then comes the f of x. What's f of x? Well, right there. That's f of x, huh? So that'll be, I hope I have room here, let me see. Minus 3x squared plus 3x minus 8. Bless you.
Thank you.
All over h. Does everybody see that? So this back here, that's, oops, come on. That's f of x, isn't it? Right? Just taking f of x from the first line up there. And there's a minus in front, and then you always got to put parentheses around the f of x because you're going to distribute through those parentheses. So I'm going to take the parentheses, now I'm going to go boom, boom, boom. So what do we got? I'm going to bring it all down here. So we've got minus 3x squared, minus 6xh, minus 3h squared, plus 3x, plus 3h, minus 8, and then distribute that minus through there. What's going to happen? What happens when this minus hits the minus 3x squared? Plus 3x. Everybody good there? Minus hits minus, makes plus. Two minuses hit, they make plus. And then minus hits the plus 3x, makes minus 3x. And minus hits the minus 8, makes plus 8. Huh. All over h. Messy algebra, huh? Right? All non-h term. Whenever you do this difference quotient thing, see, it's a difference, it's a subtraction quotient, fraction. So subtraction, fraction, a difference quotient. You know all the non-h terms are going to cancel. So that's minus 3x squared. He better cancel because he doesn't have an h. He's got to cancel, or I messed up. If he doesn't, I messed up. He does. There we go. How about, what else doesn't have an h? This guy. Plus 3x. He better cancel. He doesn't have an h. Yep. How about the minus 8? He doesn't have an h. Yep. See how everything without an h drops out? That's a good way to double check you didn't mess up the algebra somewhere, didn't miss one little sign or something. That's why I give it to my calc students all the time so they can check their work. I was just telling my son today, who's taking calculus, he was in my office doing some work for he's got a calc test when he comes back from the break. He was like, John, you want to be an engineer? Part of being an engineer is you learn to be self-critical. He messed up on a quiz question. I'm like, see, why do we know that's not true? What can you check there? And he checked it. He's like, oh yeah, that's right. So checking, so learning, so I'm giving you a checking device. So you can check that. All right, so now where do we go from here? So just what's left is left. Well, actually, that's not entirely the whole story. We got to divide off that h also, huh? So what are we left with? Minus 6xh minus 3h squared plus 3h. Anything else? That's it. Over the h. Now, remember what's going to happen on the last step? You see, what always happens is all the terms that don't have an h drop, then everybody left has an h, and one of them is canceled from each term divided by the h on the bottom. That's how these always finish up. So this guy's, he's really dividing each of those three, isn't he? He's going to divide this guy. He'll divide one of those out and this guy. It gets very predictable after a while. Minus 6x minus 3h plus 3. There it is. That's as bad as it's going to get. I probably won't give you one quite that bad. I'll probably give you one like 13. You want the whole truth? I'm probably giving you one just like 13 on the next exam. I haven't written it yet, but that's what's in my mind. I think 13 is appropriate, 14 is a little too messy. I tried not to kill you on the test, but just give you the medium level. All right.